Here we have an application of cross products to compute the volume of a parallelepiped. So let me draw that. Say we have this figure. And then this base, so we have it look like this. So this is our slanted box or a parallelepiped. We need to compute the volume of this object. Let's put the plane x, y, z coordinates here. So assume that we have three vectors correspond to three sides here. So vector v, this vectors, vector u, this vector u, v, and w, vector w. So we have three adjacent edges correspond to u, v, and w. We will compute the volume of this object by the dot and cross product of u, v, and w. The volume of the parallelepiped is the area of the base times the height. The area of the base, so we choose the base to be, this is a base. Base. So the area of the base is, we know how to compute that by cross product. Area of the base is the length of the cross products v cross w. Okay, that's the first thing. The second thing, we need to compute the height. So let me draw the height. The height of the parallelepiped, so perpendicular to the base, right? So this is the vector, the height. So actually this is the vector perpendicular to the base in this direction. So these vectors, if I use in this particular picture, if I use the right hand rule, I can see that v cross w, v cross w is the vector perpendicular, so it has to be in this line, right? In this picture, using the right hand rule, I can see that v cross w is actually pointing up. So vector v cross w is this vector. Okay, whatever its length is, but it is these vectors. Now I want to find the height. So the height is a projection of vector u onto vector v cross w. So let me project this perpendicular to here. So this is 90 degree. This length give us the height. Okay, we need to compute that. So now let theta be the angle between u and v cross w. Then we know that the height is the length of that. So if I call the vector h, then the height is the length of vector h. Then I have the height is, if it's right triangle, the length of u times cosine of the angle theta. The length of u times cosine of the angle theta. Okay, so now we have the height. Area of base, we know the height, we know where theta is the angle between vector u and v cross w. Okay. Now recall that for the dot product, we can actually find out or write down the cosine of the angle in terms of the dot products. Recall, if we have say two vectors, let me use a and b. Vector a dot vector b is length of a, length of b, cosine of the angle between them. In our case, a we choose to be u, for example. B we choose to be v cross w. Okay, so a dot b equal to the length of a, the length of u, the length of b, the length of v cross w, and the cosine of the angle between them. Okay, so we know that u, length of u cosine theta, length of u cosine theta is this dot product divided by this length. Okay, so this is length of u cosine theta, which is the height, equal to the height. So now we can plug them all into this formula. The volume of the parallelepiped equal to the area of the base times the height. Area of the base is length of v cross w. The height is this quantity. So this one is the volume. This part and this part cancel out. What we have left is u dot v cross w. Which is the formula of the volume, this formula. In this case, The formula nicely give us the dot products here, and depending on the order of UVW, so we have whether the angle theta give us a cosine is positive or negative. So in general, you just need to put the absolute value here so that this is always positive, and this is the volume of the parallelepiped.